Good afternoon, everyone. Thank you for joining us. My name is Marissa Waterman. I'm the Marketing Director here at the Academy. Here with us today, we have Robert Gardner, a board-certified environmental engineer and Senior Vice President at SCS Engineers. We also have Chaz Miller, CEO of Miller Recycling Associates. Today, Bob and Chaz will be discussing the collection, disposal, and recycling of plastics. Also joining us today is our interim executive director, Dr. Daniel Other. Dr. Other will serve as the moderator today. During the presentation, you'll be able to submit a question by clicking on the Q&A icon on the bottom of your screen. Before we get started, Dr. Other would like to say a few words. Dr. Other, how are you?
Well, thank you, Marissa. Happy New Year, everybody. Glad folks are able to join us for our first webinar of 2023. I'm glad to be here with Bob and Chaz. Today, we've got a really exciting webinar for everyone. I'd like to start today specifically by thanking the patrons of the American Academy of Environmental Engineers and Scientists. It's through their generosity that we're able to offer many of the programs to our members. In particular, I'd like to call attention to SCS engineers who are a patron. And it's through the patrons program that they're sponsoring today's webinar. That makes it free to everybody who's a member. Thank you, SCS engineers. As Marissa said, I will be moderating today's discussion, which means it would be incredibly helpful to me if you would look down at the bottom of your screen where you see that Q&A, question and answer. If you would bring that up and throughout today's presentation, pop some questions in there. At the end, I'll pull those together and I'll ask those questions in a way that's interactive with Chaz and Bob. So we'll have some dialogue here based on your questions. I'd like to introduce Bob Gardner, who's been with the Academy for nearly a quarter of a century, or as I like to say, 25 years. Bob, it sounds better that way than to say the quarter century. And thank you for serving currently on the Board of Trustees. Bob holds a baccalaureate and a master's degree, both in civil engineering from the University of Virginia. He's a senior vice president of SCS Engineers, and he's been with the firm since 1980. He serves on the firm's board of directors, and he oversees the nationwide solid waste management practice. Bob's expertise is in solid waste management and environmental engineering. He provides consulting and engineering services to municipal and private clients throughout the U.S. and abroad. Bob's involved in the Environmental Research and Education Foundation Research Council. He's a past director of the Solid Waste Association of North America Landfill Management. And I'm very proud to say that Bob is a board-certified environmental engineer of the American Academy, and his specialty is solid waste management. We're also very grateful to have Chaz Miller with us today. Chaz is a 50-year veteran of the waste and recycling industry. I guess I could say half-century Chaz, but we'll just stick with 50-year. He was part of the EPA's original Resource Recovery Program. He's the recipient of the Lifetime Achievement Award from the National Recycling Coalition. He's chaired the Aiming for Zero Waste Task Force in his home county in Maryland, and he writes an award-winning column for Waste 360 magazine. Once again, thanks to SCS Engineers. Thanks to Bob and Chaz for joining us. Over to you, gentlemen. Thank you.
So thank you for the invitation to speak. I've been looking forward to this for a while. We're going to do an overview of what we do with plastic products and packaging when we are through with them. We are not covering everything. We don't have the time or the expertise to cover all aspects of the afterlife of plastics. However, compostable plastics, for instance, are worth a webinar of their own. We will be focusing on plastic recycling because it gets the most media attention. For those of you who like to take notes, my presentation is available with the speaker notes, which has got a lot of data in them, with my contact information, which comes at the end of the slides. So what I want to talk about first, the first plastic was 1869. It was a celluloid billiard ball. It was actually invented as a result of a contest to find a way to save elephants from being slaughtered so their tusks would be used to make billiard balls. Almost 40 years later, Bakelite, the first synthetic plastic, was developed. Since then, more and more plastics were developed and over time turned into useful products. For instance, HDPE was developed in the early 50s, and its actual first commercial application was hula hoops. PET was developed in the early 70s and was commercialized in the late 70s as the PET bottle. However, there's sort of been a downside. As plastics grew, it encountered serious environmental problems, such as the Great Pacific Plastic Patch in 1997. Bag bans actually began in Bangladesh in 2002 when drainage systems were clogged during flooding. First US bag ban was in San Francisco, 2007. PFAs were found in landfills about a decade ago or so. And then just last year, California passed sweeping anti-plastic packaging legislation after the threat of a public referendum on plastics. For better or worse, plastics have transformed the world. You might just watch your activities during the next day. How many products that you use that have a plastic component, from waking up, your bed sheets perhaps, throughout the day, chairs, desk, toothbrush, eyeglasses, contacts, your computer, your car, and then relax at night watching TV in your lounge chairs. And you can decide for yourself whether plastics are good or bad or somewhere in between. I'm just here to talk about how we manage plastics end of life. Next slide, please. So what I will be covering, if you will, is a lot of data, and I'm using EPA data on plastics. We will not cover industrial waste or C&D debris or the health impacts of plastics. But again, a lot of data, how much plastics we throw away, turn into energy or recycle. I'll look at the role played by plastic in making less waste. I'll focus mostly on recycling, including markets for recycled plastics and some various policies intended to increase plastic recycling in its markets. So let's wrap ourselves up and let's talk plastics. And by the way, the picture in the previous slide, that's actually Mylar. And Mylar is a stretched polyester film made from PET. Next slide. So how much plastics? Again, I'll be using EPA data. Unfortunately, the most recent EPA data on the waste stream is 2018. It's a bit old. Can't do anything about that. I'll be focusing on what we don't use anymore and throw away, which is what EPA focuses on, not on yearly production of plastics. And it's very clear that our use of plastics has grown tremendously over the last 6 decades. You know, EPA's waste database begins in 1960 with 90,000 tons of plastics compared to 35.7 million tons today. That's an extraordinary jump. But the biggest increase, the real skyrocket, we were in the 80s and 90s when plastics really started being used heavily for packaging and electronics and other products. Next slide. And the slide just before. And if you look at this as plastic as a percentage of MSW, it was 0.4% the first time it was tracked. It's now 12.2%. One little caveat about EPA's data, they changed the way they define and track food waste, which created much more food waste in their database, and unfortunately made it very hard in the future to do comparisons with previous years. The old database plastic would have had a higher market share. And that raises a very interesting question, which I'm going to talk about a little bit, which is how much more plastic and other would we have? How much more packaging and other waste would we have without plastics? So next slide, please. EPA defines, the products category, yeah. So there should be a slide just about, okay. EPA has 5 product categories. Food and yard waste is the largest, a little bit over a third of the waste stream. There's dirt, there's containers and packaging. It's pretty obvious what that is. There's durables, which are things that last more than 3 years, appliances, tires, that sort of thing. Non-durables are products lasting less than 3 years. Printed paper such as newspapers, office paper, clothing, plastic cutlery, a lot of stuff. But you notice that 1/3 of MSW is food and yard waste. Next slide, please. Now you fit plastic in those categories. About 41% of plastics are containers and packaging. About 38% are durables. and about 21% are non-durables. And you compare that to the competitors of plastics. Paper is 60% packaging. Metals are split between cans, which are, and durables, but that's pretty much it. And glass is simply packaging. And so there's tremendous variety in the plastics. And I'm just curious right now, just think about, what do you think is the most commonly used resin in our waste stream? Next slide. It's actually LLDPE, low density polyethylene. 24% of the plastics as a resin is that. And that LDPE is like films, it's other packaging, it's durables. Polypropylene, almost as much, and it's mostly durables with a small amount of packaging. HDPE, well, it's the third largest, more than half of that is packaging. Then you have PET, which is plastics, fibers, and some other stuff. Next slide, please. So how do we handle our plastics, you know, when they become trash or other things? Next slide. Where is a way for plastics? Well, land disposal, 3/4 of the plastics that we use go to land disposal. And you notice that picture before, you know, landfill pictures, transfer station pictures, show a lot of plastic bags because of the ubiquity of the plastic garbage bag. Back to the next slide, please. And those bags are made of LDPE, LLDPE, or HDPE. And that, you know, those garbage bags are not going to be recycled. And landfill liners themselves are often made from either LLDPE or HDPE. Waste to energy gets about twice as much plastic as recycling. They're very high in BTU value, and they're converted into energy in a waste energy facility. And that displaces the use of coal or natural gas as an added benefit. Now, waste energy itself, though, is highly controversial, and it's very capital intensive, both of which I think have been limits to its growth. Let's zoom in on plastic recycling with the next slide. Now, by category, the plastics get recycled, not a lot. Durables, a little under 1 million tons. That's about 6.8% of the waste of the plastics. Non-durables, only 2.4%. Containers and packaging, only 13.6%. So you look at that, 13% of plastics get recycled. It's mostly containers and packaging. That's for a very simple reason. They're the easiest to process and the easiest to collect. They are the easiest to single out, but even that can get somewhat difficult. Next slide, please. Let's look at plastic recycling by resin. You've got PET, almost, 0.98 million tons, about 1/4 of PET. That's mostly bottles, and that's mostly PET bottles as a result of deposit legislation, which is very, very effective in getting people to recycle. HDPE, you're talking about milk jugs and other packages, and I think milk jugs are a fairly commonly recognized plastic. But then you get into all the other packaging in HDPE, the tubes, the detergent bottles, containers, just such the wide variety, and toothpaste holders, toothbrushes, it's just not heavily recycled at all. Then you look at LDPE film. Well, 10% of that gets recycled, and that is primarily film that comes from store pallet wrap. It's collected commercially, just like old corrugated boxes are collected from stores and sold for recycling. And then also the drop-off at grocery stores. But then you look at polypropylene, 2.7%, very, very low number. One thing that's very definite about plastic recycling, clear plastics are easier to recycle than colored plastics. They're not dyed, so they can be turned into almost anything. So let's look at that just a little bit more closely. Next slide. You look at the most recycled plastic products. PET bottles, almost 30%. Natural HDPE bottles, almost 30%. Colored HDPE bottles, around 18%. Although more tonnage even at 18% than the natural, which tells you something about the more limited supply of natural HDPE packages. The bags, the sacks, and the racks, only about 13%. Those are relatively small numbers. I mean, let's not kid anybody. These are low recycling rates, especially compared with their metal and their paper competitors. It's interesting that the most commonly recycled plastic product happens to be the polypropylene casing on lead acid batteries, and that's for a very simple reason. You got a dead battery, you get it to the garage, they just keep it and they sell it, and both of you are happy over that. Now, the slide that we're looking at now, because you've seen a lot of numbers and data, that's resin. That's resin. It's a picture of resin produced by EFS Plastics, which is a Canadian company. And that's one of the few companies that aggressively buys mixed plastics as a feedstock. Now, are plastics the epitome of waste reduction? The slide you're working at now is EPA data looking at per capita generation since 1960. 2.68 pounds per person of garbage, up to 4.74 pounds in 2018. Or actually, that was in about 2015. Then it started going down before EPA revised its database. Now, waste generation is caused by many factors. More people automatically means more garbage. That's inevitable. More affluence, more stuff generally means more waste per person. Plastic, however, it's had a big impact on both total and per person basis. As I showed earlier, plastic is now the third largest component of our waste stream. However, by displacing heavier glass, heavier paper products, and metal, plastics has slowed down that increase in total MSW. And it has lowered the amount of waste each of us generates on a daily basis. Now, MSW itself evolves in a lot of different ways. Printed paper has gone down as newspapers and office paper decline. Yard waste is down by 1/3 due to the rise of backyard composting and mulching lawnmowers. On the other hand, food waste has doubled. The waste stream can be very dynamic. Some things add to it, some things take away. Next slide, please. So you look at a life cycle assessment for packaging, and this explains a lot of the impact of packaging itself on the size of the overall waste stream. Lightweight rules, and that is what packaging is. It is the lightest weight for virtually all its applications and competing materials. Lighter the weight, the less the impact on the environment, less energy consumption, lower CO2 emissions, less water usage, higher product to package ratio, less trash, even if not recyclable. And you just see that in countless life cycle assessments. The state of Oregon, their Department of Environmental Quality, their Sustainable Materials Management branch web pages have some very fascinating examples of how this translates in waste for packaging. So what does all this data mean? Our use of plastic products has skyrocketed over the years. Plastics are a very significant part of the waste stream. They're found in most products out there. They've slowed down waste generation, but they're more diverse in composition, colors used, and so forth, than products made from other materials. And that means they're more difficult to recycle as a group, not necessarily as an individual product. So I want to look more, really start diving into plastics recycling, first at markets, and then at some of the barriers and solutions. But first, why do you recycle? People recycle for a lot of different reasons. They do it to lower greenhouse gas emissions. They do it to keep stuff from being thrown into a landfill. They do it to conserve resources. But once that stuff gets into the bin, all it is a raw material looking for a buyer. It's a commodity subject to fluctuating prices. And there's a saying in the scrap industry that recyclables are bought, they are not sold, and buyers want reliable quantity, they want reliable quality, and they all want all of that at an acceptable price. And what you see in recycling markets is quite often purchasing agents forecasting what they need down the road in 1 or 2 months. Prices going down generally means they are ordering fewer raw materials, or they're ordering less boxes for shipping those products. It's an intriguing economic indicator. Prices going up, especially for boxes, simply means more demands for goods. Now let's look at some markets for 2 common curbside recyclables. I chair the Recycling Markets Task Force for the Northeast Recycling Council. And for about 3 years now, I've been doing slides for NERC and the task force, tracking 8 different curbside recyclables. And I just have some charts up here, one for natural HDPE. And all the slides that I do, all the charts that I do for recycling, any charts you ever see that show more than a year or 2 of recycling data will show a lot of ups and downs because these market prices fluctuate. It's the nature of those markets. Natural HDPE currently is 65.75 cents per pound in the Northeast. It's actually the second most valuable material in the waste stream. It's also the only one whose value has gone up in the last 4 months. All the others have gone down over this last month. They've all been flat with another exception. And why? It's partially because it's turning into more demand than anticipated for natural HDPE. And the actual supply is fairly limited because our use of natural HDPE is fairly limited. Now, the picture you're looking at now is PET. PET, you're talking water bottles, you're talking soda bottles, you're talking also clamshells and other things for a lot of different food products. It's 11.25 cents per pound. And you see that extraordinary dive in the price of PET from last April. That was caused by 1 or 2 unusual incidents in the industry, and then a free fall when those stopped, when that particular buyer dropped out of the market and prices and this normally happens. Those are the summer months, April, May, June, July, when consumption of drinks in bottles really soars. So normally prices are very strong through the summer, but the fiber markets pulled out and the prices went down dramatically. This is very common in recycling. Next slide. You've probably heard a lot about exports and how we're dumping all our garbage on China or what have you. Certainly that's the feeling you get from a lot of press coverage of plastic recycling. Next slide. It's not true. Our exports of plastics have gone down dramatically. Granted, part of that did result from China when in 2017 it banned the importing of all non-metallic recyclables. However, both HDPE and PET, their exports had started declining in 2010 as larger domestic markets grew. Currently, we ship about half of our recyclables that do get exported, go to Canada or Mexico. I'm talking about the plastic recyclables. And that's probably not going to change. At the end of this year, we will be under 1 billion pounds of exported plastics. And it's interesting to note that now some European companies, Germany being one of them, are starting to become larger importer of plastics, apparently to meet some of their domestic recycled content requirements. Next slide, please. So let's look at some market myths about export markets. The myth that the US dumps its trash on other countries. That is just wrong on its face. It's too expensive to ship garbage overseas. The closer you are to a disposal facility or a MRF, the happier you are. Virtually all US garbage stays in the States. Fact, paper and metal recyclables have been exported for decades without any controversy. And we measure those in millions of tons, whereas we measure plastic exports in billions of pounds. And that's largely because we just don't export that much plastic for recycling. It's just such a small amount. Now, it is very true that there are some unscrupulous recyclers who salt bales with non-recyclables. I think every newspaper, every paper mill in this country that buys OCC or other grades of paper recyclables has found cement blocks and other stuff in bales of paper at various times. Usually what they do is they never buy paper from that recycler again. But, it's pretty swift in the punishment. But it does happen. It's an unfortunate reality of the business. Next slide, please. Let's look at recycling market trends. Plastic demand is high based on commitments to use recycled content. Recycled plastic supply is incapable of meeting those commitment demands. But those commitments can be constrained by overall raw material costs, especially when the procurement agents start looking at what they're paying for plastic recycled versus virgin. And that is a reality. Economic trends are important. Is the economy growing or is it contracting? Do end markets need more or do they need less raw materials? Right now, we've got a contracting market. With the exception of natural HDPE, every single recyclable came in at a lower price at the end of 2022 than it did at the end of 2021. Natural being the only exception to that. The economy is not growing. It not really grow in 2022. And it's going to take growth in the economy to really bring back your recycling markets, including those for plastics. I think the Infrastructure Act is going to be very good for some recycled plastics because polypropylene, color HDPE, and some PET and some natural HDPE definitely rely on construction markets as their end markets. You've got competition with virgin resin, which is usually less expensive. And you're also affected by the price of oil and gas. And it's worth noting that both Brent for oil and for crude oil and Henry Hub for natural gas are near the lowest mark that they have been in the last 52 weeks. Those prices are going down dramatically. Now, what about barriers to plastic recycling? It's actually fairly simple. That thing that makes them so strong in LCAs, it's lightweight, makes them very hard to process. In addition, you've got a very wide range of products. You've got electronics, you've got eyeglasses, you've got toothbrushes, you've got furniture, you've got packaging of all kinds of varieties, you've got clothing. And extraordinary, you just don't see that with other materials. You have a wide range of resin. Paper is made in one of two ways. It's either groundwood or it's a craft chemical process. Glass is made and aluminum and metals are all essentially made in exactly the same way. It's different with plastics because of all those different resins and also that very wide range of colors. And that composition can change as new breakthroughs in chemistry and in technology. It simply means they are harder to recycle than paper or metals. And like paper and metals, they are stuck with fluctuating markets. That one, nobody has figured out how to get away from. So how do we fix plastic recycling? And you hear a lot that plastic recycling is broken. I think that's a bad analogy. It's an easy one, but it's bad. There's nothing broken about recycling. Markets go up and down. Nobody's ever going to fix that. But plastic recycling does have some very unique problems caused by a lot of those barriers that I already mentioned. So in the next few slides, I'm going to look at a number of proposed ways to increase recycling. Some are demand side to increase recycling. Some are supply side designed to increase the amount of stuff out there to recycle. Few, if any of them, take human behavior into account. And that's an important flaw of so many of these realities. They're all about policy. They're not about how to get people to recycle more and better. And we've got to start really focusing on that. So looking at policies to increase demand, recycled content, either as part of extended producer extended producer responsibility laws or standalone laws. Right now, there are very few states with the recycled content laws. And there were those that are out there are like, 25% in 2025 or something. And the experience with recycled content laws for newsprint showed that it was nice to have them, but they did absolutely nothing to insulate the price of old newspapers from the normal economic fluctuations that happen in any economy anywhere in the world. You can also do government procurement requirements. Companies can have their own procurement requirements to increase demand. That will help. Let's look at policies to increase the supply side. There's mandatory recycling. A lot of states have mandatory recycling laws. They vary widely. And few, if any, states have actually met their goals. And the goals are all interesting. And the one thing that connects all the goals together that is uniformly consistent with these goals is every recycling goal out there can be divided by the number 5. We're not talking rocket science when we came to setting these goals. We're just talking individual legislators' aspirations for where recycling should be. 10 states have bottle deposits, easily the most successful form of recycling. Consumers have an immediate incentive to get their deposit money back. A lot of interest in extended producer responsibility with the theory of internalizing waste management costs into a product's cost. And that therefore will mean the packagers and others will seek more recyclable materials in order to pay lower fees. However, the reality for packaging in particular is the per package fee is weight-based. And that means the lighter the package, the lighter the fee. For some packages, you have fees that are in tenths or hundredths of a cent. This is not a fee that is going to have any impact whatsoever on packaging design. And in fact, that's what we've seen in Europe, simply no impact on product design. It does increase recycling, although I think local culture plays a bigger role. There are now 4 existing states, EPR programs in the US, besides container recycling laws. California, Maine, Oregon, Colorado have all enacted laws. However, implementation is really not going to begin until 2025. So nobody really knows how these laws will work out in a country such as ours, with a wide variety of how we manage our solid waste. So let's end up with mechanical or non-mechanical processing. And you got mechanical processing. It's what you see at the material recovery facilities. There's about 375 of these across the country. They use a variety of technologies to separate out different plastics for end markets. Chemical or advanced or molecular or whatever you want to call it processing, recycling, has the potential to process a much wider array of plastic products and resins. Less than 10 facilities are operating in the US. Non-mechanical recycling really needs to make the transition from academic papers and from press releases announcing new facilities into actually operating commercially sized facilities. There are a lot of issues connected with this. Is creating fuel recycling? Some people are adamant that isn't. Facility siting is always contentious. And industry does promote legislation right now to classify chemical facilities as manufacturing and therefore exempt them from waste regulations, although they've never offered an example of where waste regulations create problems for these facilities. Now, I regret I don't have the picture of this for this presentation, but I did use it as it turned out in my NERC presentation yesterday. In Baytown, Texas, ExxonMobil opened its advanced recycling facility on December 14th. They use what's called the Extend technology to process up to 80 million pounds of hard to recycle plastics and transform them into raw materials. It's a form of pyrolysis that co-processes the shredded plastic waste directly. They mix it with other hydrocarbon streams. They say it allows more recovery of molecules than a typical standalone pyrolysis unit. They're kind of vague on the input. They talked about shredded pre-processed plastics ranging from synthetic athletic fields to bubble wrap to motor oil bottles, none of which really get recycled except for bubble wrap you can recycle. They're drop-offs. During the pilot process stage, they sold about 15 million pounds. So they have some track record behind them. And it's going to be interesting to see how this plays out in terms of truly advancing recycling. If the process works, if it doesn't. I don't have any bias whatsoever to chemical recycling or whatever we want to call it. But I'm still waiting for it to prove that it works and that it proves that it works at commercial scale, and where it's going to get that supply of materials. I'm sure it's going to get a lot of post-industrial and off-spec plastics. Where is it going to get the supply in terms of residential waste? And the final slide, please. So, in a lot of ways, managing plastics is like a puzzle. It's complicated, especially if it's one of those 1,000 or 2,000 piece puzzles. But from a waste management perspective, the answers include reduction, they include recycling, they include waste energy, they include land disposal. The puzzle is simply putting them all together and making sure it all works. And then in my final slide in this is my contact information. Happy to answer any questions you have offline. Also happy to send you a copy of the slides with all the speaker notes. So Bob,
Thanks.
take it away.
Thanks, Chaz. Bob, over to you, sir.
Oh, thanks so much. You know, as Chaz indicated, plastic has many faces. And my focus in my talk today is to talk about some of the practical aspects of the many faces of plastic and how we're kind of dealing with it on a real-time basis. So you have, like Chaz indicated, you have the PET, the HDPE, polyethylene, polypropylene, polystyrene, polyvinyl chloride, all of which have different characteristics, different resins, and different challenges associated with ultimately recycling. And as we indicated, the many forms of plastic that you have and the forms that they have, and all these things are important relative to how you ultimately will process a plastic. If you have mechanical separation, you're dealing with form, you're dealing with size. You've got to figure out how to segregate these materials, and these all pose challenges. And so you look at the modern day recyclable facilities that are out there, they're all designed to really get at the issue of size, form, and characteristics of those materials. We'll talk about that in a moment. So it makes it very challenging. As this slide shows, on the many forms of plastic, the PET and HDPE are the most recycled plastics out there. Relatively simple to do through the technologies that we have. Polyvinyl chloride, very difficult, and folks want that out of their system to the extent they can, especially if they're going to go any other processes that require using it as a fuel or whatever you want to get that out, because that creates some air emission issues. LDPE, polypropylene, again, are more manageable. You can get at those through some of the technologies that we are deploying at this juncture. And then the polystyrene and other plastics are much more challenging to deal with. Now, there are many trains of thought with regards to plastic recycling. And some argue that plastics are here to stay and we need to develop the processes for effective collection and ultimately the processing and separation of these so that they can be recycled. There are others who advocate that extended producer type responsibility processor policies need to be employed where manufacturers are responsible for the ultimate handling of the waste that they produce through their packaging. While others suggest that similar to glass, we need to have the buybacks, as Chaz had indicated. There's others who say that plastics recycling is a farce and that it just will never work and we need to get rid of plastics altogether. And I think as Chaz had indicated, I think plastics are probably here to stay. I'll say they are here to stay. They probably have provided some real benefits to society, but also have created some challenges that we're trying to ultimately deal with. And as Chaz indicated, we have various policies and bans and fees and taxes, all that provide incentives to figure out how can we best recycle these materials. And there is a push by various capital markets to bring new technologies to the table in order to try to take these plastics, some of these more difficult to handle plastics, and can we do something and can we produce a fuel product or some type of end product that can ultimately have some benefits. Well, from a practical perspective, and this is kind of similar to the one that Chaz showed, and these slides are important from from the perspective of the recycler, and the person who is actually processing the recycling facilities, because many of these facilities are let's say, dealing with municipal types of collection. And so they have long-term contracts that they've developed for collecting and processing of recyclables. And one of the challenges is, if you are a recycler and you're going into a long-term contract, and in the past, these contracts in many cases were on a fixed price perspective, so to speak. In other words, I'm going to be paid a certain dollar per household per month, and I'm taking the responsibility for the markets. In some cases, they were sharing of the value of the markets or the profits that were coming from those markets. But I think, as I'll show in a moment, because of the high variability in these marketplaces, and this is again showing how between two different markets on the PET versus the HDPE, markets can just vary all over the place. And if you're a business person and you're dealing with the financial side of these and you're a private operation, your return on investment is important. So figuring out how you can ultimately develop your system, operate your system in a manner that provides you a sufficient rate on return, that's really critical. And so in terms of I'll talk about in a little bit, in terms of the strategies that many of the privates are taking at this juncture, will be something I think you might find interesting. Really, the end game, or the holy grail of plastics recycling, is to be able to segregate these materials faster, more precisely, by material, composition, color, opacity, form factor, so that you can have a higher quality material that you can sell, you can take to the market. I was involved with one project in the last year in this particular acquisition, where the recycler was able, through the China Sword, to continue to sell their product at a higher price because they had developed processes that produced a product that wasn't going to be shunned from the marketplace in China, for example, because of contamination. So they had figured out the mousetrap, so to speak, on how to produce a bale of plastic or metals or whatever it might be that continued to have a high value, and they were able to sell it at a good price. And so the approaches that you have in terms of dealing with plastics in particular, you can either do mechanical separation or optical sorting with some type of artificial intelligence, which is the primary means that people use for segregating the different types of plastic. And so the technologies that you have from the major equipment manufacturers that are in the marketplace generally take very similar approaches. You've got your size segregation, and I'll show a couple pictures in a second, the trommels and the screens that are in place in order to begin to break down. If you're dealing with a mixed waste recyclables, or if you're dealing with an MSW, you're going to have to begin to break down your various components. And fortunately, plastics, except for films and small things, are generally able to begin to be segregated by size. And so that's usually the first parts along the way that you begin to segregate out your fibers, your plastics, your metals, and so forth, and get those out of the way. You also have manual separation that occurs, where you have picking stations where people either negatively or positively are removing materials or picking materials in order to segregate those. And depending on your process that you have, or what your end market is, you might have some shredding at some point. If you're going to be developing, sending things for a fuel product, for example, you might have some shredding along the way. And most advanced recycling facilities also deploy 2D and 3D sorting. And then with the optical sorting that is out there and dealing with the plastics and the fiber, you can begin that process of separating the PET, the HDPE, the LDPE along the way. And I think one of the interesting trends that are happening in the industry at this juncture is the deployment of artificial intelligence and robots in order to begin to identify on a very quick basis form factor as well as material type, using various kinds of processes, LiDAR and the like, in order to begin to do those separations. And then you have pneumatic separation combined with optical that can begin to get at things like film, which are really difficult when you're going through mechanical processes. So some of the general processes and goals associated with those are really a function of what your end product goals are. So for example, if you're looking for an engineered fuel, you're going to want to have to go through a process. If you're dealing with your feedstock is source separated materials, you've got a process that you're going to go through. If you have materials that are mixed waste, you have a process that you're going to go through. But the typical sequence that I've seen in various facilities include the bulky, removing of the bulky items to get those things out of the way that are problematic, not only for your equipment processing, but also problematic from an end product perspective. You're going to screen out your inerts and organics, and there's a stream that then can go and do some additional processing. For example, if you want to deal with food waste or organics, that you might go to an anaerobic digester. You're going to then, by size, by trommels and other screens, you're going to begin to segregate the size, breaking it down, let's say 12-inch minus, 12-inch plus, then going into 4-inch minus, 4-inch plus, whatever along the way in order to get at those materials. And then your 2D and your 3D material removal, which includes your corrugated cardboard, your number 1, number 2 plastics, and then taking those separate streams and typically using optics in order to begin to separate those out and deal with where your end products are going to be. As a general goal, well, we've seen that the market would like to see a 94 to 96% efficiency for capture of targeted materials. That's a challenge with a 92% purity on targeted captured materials. Here's a couple of shots of a facility that I was involved with. Again, this is a picture on the top left that looks at your sorting areas where you do those negative and positive sorts. The bottom right just shows a shot of the front end of one of these facilities. They're wonders in terms of putting these things together. And this particular one was fascinating in that it was all engineered where you had equipment coming to within a 1/4 inch of all these columns. And the technology they now have in order to do these things in 3D is pretty amazing. It's a shot of a bag breaker and a trommel screen. Again, that initial process of breaking bags open and getting the material that's in those bags so that you can begin to recycling. Disc screens, again, to deal with the 2D and 3D materials as you begin to segregate those materials out. And the heart and soul associated with plastics recycling is the plastic optical sorters. And there's various technologies, and this is one in particular that was used at the facility that I was involved with, where they begin to segregate the PET and the HDPE materials in particular. The ultimate goal on a facility is an end product. So in plastics, you're going to be having PET and HDPE bales that you're ultimately going to generate. You might have your OCC bales going along the way. And the key is that in all these processes, as I indicated, you want to have a bale that has very limited contamination. You may have your end products might be an engineered fuel, and this is a case on the left side of the screen. These are engineered plastic fuel pellets that were being generated mostly from films from a recycling facility. And on the right-hand side is a cellulose pulp material. And either can be used for feedstock to a pulp and paper mill or as a fuel going forward. So what are processors doing today? And what are some of the issues that they're facing with? As we indicated, the challenge really is the falling blended commodity values in 2022. And as Chaz indicated, historically, that's been the case. So in Q4 2021, your blended commodity values and blended commodity values would be you take all all the products that you've generated, the dollar amount that you're able to get for it, and that's your blended on all the various products, and this is your blended value. So Q4 for Waste Management reported $132 a ton. Q3, it was down about $40 a ton to $94, and expected to go down to $50 a ton. Q3 expected to go down in Q4 to $50 a ton. So if I'm a business and on my revenue side, I have over a pretty significant reduction in my revenue side, that can really cause some stresses along the way with regards to the performance of your facility. So what are they doing? Almost all of the majors, whether that's Waste Management, Republic, Casella, GFL, all have reported in their public statements that what they're doing is trying to move away from commodity price-driven returns into a fixed processing fee. So what does that mean? As I indicated, in the past, many contracts were written where there is sometimes a revenue sharing associated with the sale of recyclables, or some just taking it at risk. And the problem has been if you go at risk, you have at risk of that facility actually shutting down. And I've been involved with projects where that's happened, where there was assumptions made with regards to the revenue side, which didn't happen because the market fell apart. And in the case of a private facility, that can lead to be shut down, and which can cause some really serious disruptions to communities that are dependent on these facilities for processing either their MSW or their recyclables. So what various folks are trying to do is to negotiate contracts where you cover your needed revenue relative to having an appropriate rate of return that does get covered in a tip fee, so to speak. So that really does provide more consistent revenues that weathers the ups and downs, provides a more secure financial basis for both the privates and the communities to continue their programs for recycling. Because the worst thing you want to have is a facility that you're depending on, that you've contracted for, they go bankrupt or they go bottoms up, and you no longer have that, and you have to either take it to a landfill or take it to a waste energy facility, spend more money associated with the transfer of this material to its end use. So in order to, I'll call it, squeeze the turnip, so to speak, and get more juice out of this, the various processing facilities are really employing more technology, the artificial intelligence and robots, in order to segregate these materials, identify them, break them apart, so that they can ultimately be a higher value end product associated with the recycling. And that is really the holy grail, is employing these technologies. And as Chaz indicated, there are a number of folks who are trying to develop facilities that will take plastics and to turn them into other products, whether it's a fuel, a diesel type of fuel. And there are several facilities that are out there that are in call it startup and testing to demonstrate their reliance at a scale. And there's some pretty significant facilities that have been constructed, significant capital that's being deployed to be able to do that. And I really encourage you, if you do have a chance, to sit in on the quarterly reports from some of the majors. You get some really good insights in terms of what people are thinking regarding the technologies that are out there. And so again, thanks so much for listening to us. And Dan, I'll turn it back over to you.
Oh, fantastic. I'll just hit the points on this before we stop doing the screen share, but just one, right? We'd love people to be able to attend future webinars. If you'd like to watch this webinar again, we do post this online, so folks would be able to take a look at it. If you're not a member of the Academy, we'd like for you to sign up. If you need PDHs for us, we'll be emailing a certificate. And if you got questions, reach out to Marissa. Bob, I'll ask you I think you're doing the screen share. This brings us back so we can kind of chat. So Chaz and Bob, there were a lot of questions, and I'm going to encourage folks to approach you individually with specific ones. But I took overall, and I broke these down into 4 different categories. So let's have a little bit of a chat here. Some of the questions fell into the category of the origin of the problem, right? In other words, like, what are we making plastics from? And could we do them from bioplastics? And would there be other degradable things? So there's a category of questions there. There was a category of questions around recycling. You know, some folks said, there was actually a letter from an EPA regional administrator that simply said plastics recycling is not going to ever work. So stop, and there's the whole question of single stream. And there's this, well, it works in other countries. How come we can't get it right? So there's this recycling question. There's this alternatives to recycling question, right? Can we put it in an infrastructure products? Where else can we stick this stuff? And what quality does it need to have to put it in different places? And then the final question was in this, how do we do better, right? I mean, should there be some national law about container reuse? Should there be some buyback programs? What should academics do? Is there funding for this? So we'll take them one by one, but I just wanted to kind of give you the sense of where we'll go. So let's start with origin of the problem, right? So we've got plastics, right? Do we have to have plastics? Could we do something else? I mean, what are your thoughts?
Give you an example. I'm sure all we did the last 2 years when we were during the pandemic, we all got a lot of deliveries through Amazon to our doors. And I was always fascinated. And this is just maybe because I'm in the solid waste business. And I always would look at the packaging. And there were some suppliers who were very conscientious. They made a decision that I'm going to package this thing. I got a pair of shoes from Murphy and Johnson the other day. Came in a great cardboard box. There was no plastic at all. Well, there was. I'm sorry. There's a bag inside that I guess kept the leather together. There was a film, but everything else was paper. Even to the detail of a little tie around the string for the strings of your shoes was a canvas kind of material, a twine, where before it probably would have been plastic. But so somebody made a conscious decision in packaging to change. And I think part of it is there needs to be some conscious decisions. And I think Amazon, reported in terms of some of the things that they're trying to do to change their packaging, because they've got some challenges. We do a lot of waste characterization work. And one of the things that comes out is on those pouches, you got both fiber and plastics that are fused together, and they're almost impossible to separate. And so some of it is a matter of decision to change. And some of this Chaz talked about from a policy perspective, in many cases, unless you have strong sustainability goals by your corporate that says, hey, we need to think differently and do differently, then sometimes policies have to come in order to force folks to change the way they ultimately packaging. Because people say it's not a recycling issue, it's a packaging issue. And so it's packaging which generates it, and there may be some other form factors that may be useful.
Perfect. Thanks, Bob. Chaz, thoughts on that? I mean, bioplastics, alternative to plastics. I mean, as long as we got petroleum and natural gas, there's probably going to be a plastic something made and used somewhere. But,
actually, there's a lot of things for which there is no good substitute for plastics. A lot of medical equipment in particular. I had the unfortunate experience 2 summers ago getting cellulitis. And as I was on the gurney in the intensive care unit, I didn't complain for a split second about the plastic IV tube or the plastic packaging for the medical packaging. And I've seen some of the even most zealous anti-plastic people starting to pull back from a world without plastic to, well, maybe we do need some of this after all. That's the first thing. The second thing is it gets back to that lightweight quality. The analogy that Bob is using about Amazon and packaging, Amazon is actually starting to right-size their packages. They've actually cut back on the amount of corrugated boxes they use as the outer package. And they've increased the amount of flexible packaging they use as the outer package, whether it's all paper, all plastic, or a mix of the two. And what they're looking at is simply light as weight as possible. And it can be recycled, that's great too, but it gets back to that lightweight as possible. And I think this is the dilemma when you say no more plastic. What's your substitute? And what is the impact of that substitute on greenhouse gas emissions and on the use of energy? Because you can't just wish this stuff away. You have to have an alternative. And if you really care about the alternative, you damn well better be checking out those LCAs and figuring out what the true impact is on energy use and energy costs.
Yeah,
I think there's a lot.
I remember an early one on those, the surgical mask versus their homemade mask, and the LCA that were fascinating. So
yeah, and the other thing is I think there could be a lot work done on reusables and more, because you can get beer in a reusable, you can get soft drinks, water in a reusable, but we also have to accept that's a major behavior change for the American public. And you can pass all the policy you want. People have to be willing to do it.
Well, and that kind of comes to the second question about recycling, right? So single stream, mixed stream, separated stream. Bob, you were touching on the technology, and it feeds into what you use it for, right? I mean, it's great to collect this stuff, but if you're going to then make that the feedstock for the next process, how high a quality and how pure, and and how do you optimize the transportation costs that are going into pulling all this stuff back, because that plays into the whole to China, not to China. So Bob, can you speak to some of that in a broader?
Yeah, sure can. I mean, the issue of single stream, dual stream kind of recycling is one that's playing out across the country, and you have ardent supporters of both of them. Single stream, I suspect, is here to stay. Again, from I'll call it the long-term life cycle cost perspective. I can collect more materials at a cheaper cost, safer than having people having to get out of the truck and deal with different containers and whatever. Although there are adamant supporters of both, and both are effectively used. I mean, the really issue comes down at the processing side and on the end product side. So if I have a single stream recycling facility and I've got 50% contamination, which happens in a lot of places, that has a couple of implications on the cost of my processing side and the cost of the residual disposal, as well as the quality of the product that I generate. So if I've got somebody who's throwing in pizza bags or plastic film when they're not supposed to be put in plastic film, that ultimately can get into bales, and that can reduce the value of that recyclable in the end market. And so, for facilities that are doing dual stream recycling, for example, and dual stream, for those of you who don't know, where you have a separate container for fiber and a separate container for all the other materials, you generally can garner a higher price on the materials that you sell, and that's a fact of life. And so it really comes down to a balancing the efficiency of collection materials, single stream, or more responsibility on the person for segregating the materials and having different kind of collection trucks in order to deal with that. So it really is a challenge for sure. And there's no perfect system, and people have their different opinions as to which is the best way to go.
Perfect.
Yeah, single stream actually began in Seattle in the late 80s when one of the two haulers that did recycling in Seattle decided he wanted to cut his collection cost and concentrated more on the processing side. But at the time that was done, you were dealing with only collecting newspaper, PET bottles, metal cans, and glass bottles at the curbside. A much different recycling stream than Seattle itself was collecting within a decade. And that's one of the problems with single stream. It may well have worked on a smaller universe of recyclables. Whether or not it works on a larger, it's simply harder. Now, interestingly enough, Waste 360 today carried a press release about a study that was just released from the Florida Recycling Partnership at the University of Florida that looked at higher contamination rates, processing costs, et cetera. I happened to download a copy of the paper shortly before this webinar, but I have not had a chance to read it. But one of the things they are saying in so many words is, let's concentrate on the majors and not worry about the minors. In other words, concentrate on those things whose recycling has the greatest impact on lowering greenhouse gas emissions. and don't worry about a lot of the other stuff. They're talking about OCC and paper and PET bottles.
People were asking, what's OCC, Chaz?
That's a great question. I appreciate that. I have the flaw of jargon. OCC is old corrugated containers that everybody calls cardboard boxes. Thank you for that.
No, because I saw it in the chat. One of the other ones that people ask is, the status of the national resin codes, right? I mean, and how that feeds into it. And yeah, do you have any update on where that's at and how folks can help in that in terms of the recovery?
That's up, frankly, to Congress and the FTC, and a lawsuit in the state of California. It will take a lot of work because I think.
Do you want to just explain that? You want to explain the topic to folks? Because I think the question.
Thank you.
Maybe
well, Bob had a slide with the 7 types of resins and the code for those resins. The 1, 2, 3, 4, 5, 6, and 7. 1 for PET, 2 for HDPE, 5 for polypropylene, 7 for other. They actually were started by ASTM in the late, like 87, I believe, was the first legislation. The idea was just a simple way to help with processing at much, much smaller, more primitive MRFs when there were virtually no plastics being collected for recycling. They sort of became everybody's guide to plastic recycling, which is what they were never intended to do. And I think that's a major flaw with them. The FTC has recently announced that they're asking for comments on their so-called green guides to environmental marketing claims. And by implication, that includes those plastic recycling codes and and whether or not they're needed or not. Personally, I could see them disappear tomorrow and I wouldn't lose a split second of sleep over it. I don't think they provide a useful function anymore.
Fair enough. Fair enough. So Bob, what, down this pathway of thinking policies, et cetera, right? So national container deposit law, are there states doing extended producer buyback? rules? I mean, what's it looking like in that legal space? And I mean, that's asking a lot to read those tea leaves, but what do you think?
Yeah, in preparation for this presentation, I did kind of run through and print it out in my mind and look at what each state was doing relative to policies enacting, and it goes all over the board, from plastic bag bans, which is the real popular one. And that's, I think about the example, it was 2015, I think, on the Outer Banks of North Carolina, they banned plastic bags. And then a couple years later, they said, nah, that's we got in order to get all those groceries up on those counties, we got to have these plastic bags in order to do this. So they backed off on that a little bit. And other states, however, have, you go to California. I have a son who lived in California for a number of years. Every time I go shopping, if I wanted plastic bags, I got to pay for it, and so I got to stop and think. And I think that's part of the whole thought process, is if you put policies in place that says we want to change behavior, well, one way to change behavior is go to your pocket. If you impact your pocket, say, well, maybe I will go buy that canvas bag and remember to put it in my car. So when I go to the store, I don't have to spend 10 cents on a plastic bag. And those are the kinds of things that you do. And I think states understand that, and to the extent that they have the guts to do it. Unfortunately, a lot of this stuff comes sometimes to politics, and we all know how divisive at this juncture that is, and how that becomes a red and blue issue. I don't know, but it does. And so you got folks who says, I don't want you in my shorts, so to speak, and I don't want government telling me what to do. And other people saying, well, what you're doing is causing difficulty, whether it's in the rivers and streams with plastics all over the place, or causing problems in our processing systems. It varies all over.
Plastic pollution, a lot of problem there, a lot of different. One of the questions that arose here was also from the perspective of, what's next? What can we do, right? So academics asking the question, what do you need us to research? Practitioners asking the question, where do we get funding to be able to implement programs? So can you speak to some of those, the folks who, I want to jump in with both feet and do something good here. Okay, how? What's my next step?
Well, on the funding, EPA has got beaucoup grant programs at the moment, and to the best of my knowledge, they're still taking applications on those grants. Check with EPA.
Is that to implement? Is that municipalities implementing programs?
It's a variety. It's for a variety of different reasons. The Infrastructure Act it's got some language in there about grants. So there's some options out there. Frankly, the most important thing, academically, is somebody could come up with good research on behavior change. The reality is about 1/4 of Americans could care less about recycling. They've got other priorities in life. And we're not a country which is, shall I say, rigorously obsessed with following the minutiae of the law. We are Americans, and we can be somewhat casual about the requirements that are placed upon us. And we need some really good understanding of behavior change and what really works. Garbage is easy. You just put it in your can, put it on the curb, and wave goodbye. Recycling is more complicated, and it's getting over that hump and getting more and more people to buy into it and doing it right.
It's interesting. I mean, I think about the economics of things, and I know of situations where recyclers have made decisions to take it to a waste energy facility versus putting it through their processing facility, because it came down to a simple cost. It is cheaper to go to the waste energy facility, pay a tip fee, it gets burnt, it gets energy, versus taking it to their own facility and processing it and trying to sell it on the market. And so it's fascinating. And it's caused some real interesting discussions in various communities as to saying, well, I'm paying to have it recycled. Well, they say, well, this is kind of recycling. It's going to a waste energy facility. And so it's really fun to see the various debates on that.
Yeah, to get back to your question on legislation, Congress is so riven with discord. I don't see reason to expect anything out of Congress in the next 2 years. Interestingly, though, the federal legislation that is passed on recycling, the Save Our Seas 1 and Save Our Seas 2, which did include some modest grant programs for recycling, those were not just bipartisan, but those were sponsored by key members in the House and of the key committees in the House and Senate responsible for that legislation. So Congress is capable, when they see something where they can reach across the aisle and come to an agreement on. You're going to see a lot more action though at the state level. I think you'll see a lot of labeling legislation. I think you're going to see more recycled content legislation. Hopefully it'll be written well. And you're probably going to see some more EPR legislation for a lot of different things. I think New York just signed into law, carpet law, and Oregon did a mattress law, or vice versa. South Carolina updated its electronics EPR laws. There's a lot of things that can be done in that area.
Fantastic. Yeah, and of course, we got to get this stuff right, because eventually we're going to have all these electric vehicles and components from those to deal with. And so there's going to be all kinds of value added parts of our recycle stream to deal with. So
people are trying to figure out now what to do with wind turbines and solar panels.
What do you do with fiberglass? What do you do with photoelectric? Yeah. No, there's a lot, it's just plastics is going to be, plastics is a part that's out there, and it's just going to get bigger and bigger in terms of what things we do and how we remanufacture. So, well, Bob, Chaz, did you guys have any final comments before we wrap up here?
Just encourage. I mean, it's funny how, right before this, we started the session, I was going through my email and I get a daily, news kinds of things. And the one that popped up today was an interesting. I don't know if you can see this. National Waste and Recycling Association just published a white paper today, or at some juncture that was just at least on the news. I encourage you to go to the NWRA, and you can download a copy of their white paper on dispelling the plastic recycling myths. Kind of, Chaz, you talked about the myths and stuff, and they have a nice, it's a page, 3-page synopsis of some of the issues that are most out there. So that's pretty interesting to go take a look at. I think plastics, probably in the last 5 to 6 months, I've spent more of my professional time on the issue of plastics and trying to come up with figuring out what to do with those than on just about any other subject, because there's some significant capital that's being deployed, and folks are building facilities and trying to make them work. And I'll just say this, dealing with either MSW, mixed municipal solid waste, or source separated materials, it's just hard. It's just hard. It's the only way I can describe it. I've sat at many facilities and just watched these mechanical processes that get all wrapped around the axle when you have something come into it like a piece of rope or a hose, shut you down. It's just hard stuff. But we're working through it, and people are coming up with technologies to solve it. I'm optimistic.
Thanks, Bob. Appreciate it. Appreciate it, Chaz. Well, thanks, gentlemen, for both.
My pleasure.
I'm going to turn it back to Marissa to wrap up here. Marissa?
Thank you.
Okay, thanks everyone for all your questions, and thank you, Bob and Chaz, for sharing your knowledge with us today. If anyone would like to reach out directly to our speakers today, feel free to email them, and we can put their email addresses again in the chat here. Or you can just email me, and I'm happy to share their contact information with you. We've enjoyed being with you today, and we have several webinars planned in the near future, so you can go to aaes.org/events to check them out and register. And if you're interested in sponsoring an upcoming webinar, please reach out to me directly. Just a reminder, if you're not yet an AAES member and you're considering joining the Academy, you can email me on that and we can discuss the membership options available. And last but not least, the PDH certificates for this event will be sent out shortly. That's all for today, and thank you so much. Have a great day, everyone.
Thank you.
Thank you.
Bye.